Hey, welcome to part 3 of the equivalent fractions video. In this video we will be looking at how we can find the lowest, or maybe not the lowest, but a common denominator to help us find equivalence so as to compare and order fractions. So if we have a look at two fractions here, we have got 2/3, 2 out of 3, as you can see a representation here. 2 out of 3 parts of this rectangle are green, and we also have 3/4 or 3/4. So as we can see in this representation, 3/4 or 3/4 of this square are green. Now in the last video we looked at, if we wanted to compare fractions, we need to change one of the fractions so that it has the same denominator as the other one. When we look at these fractions here, we can see that the denominators are causing us a little bit of problem. The reason being is we can't change one of these fractions so that it has the denominator of the other, because 4 is not a multiple of 3 and 3 is not a multiple of 4. So what we're actually going to have to do is change both fractions into equivalent fractions so as to compare to see which one is bigger. Now to do this we need an extra step at the beginning, and that is to find what is known as a common denominator. Now what that means is a denominator that both of these fractions will have if they're equivalent. So we need to find a part that we can split these fractions into so that we can we can order and compare them easily. And this is what's known as a common denominator, which is fairly self-explanatory. That's a really dodgy M. Let's try that again. Sorry, I'm going to have to concentrate because this is a word I often misspell. Okay, so our first step is we need to identify what the denominator is we're going to have to use for both of these equivalent fractions. Now there's a couple of ways of doing this. The first way is to use our knowledge of the times tables to find a number that appears in both of the times tables of 3 and 4. So the first method is to find a number that is in the same times table as both denominators. So in this case the 3 times table and the 4 times table. Now if you're very good with your 3 and 4 times table, you'll be able to do that in your head. Another way could be just to write them out. So let's do our 3 times table. 3, 9, 12, 15, 18, 21, and so on and so forth. I'm not going to go through the whole times table because there'll probably be an equivalent one early on, and if there's not, I can always keep going. So I'm going to do the same. I'm going to write out my 4 times table next to it to see if there's any numbers that appear in both. So 4, 8, 12. And here you can see that 12 appears in both times tables. So this is going to be our common denominator. This is what we're going to change both of these fractions denominators to. So that's one way of doing it, is to use your knowledge of the times tables, and that will help you identify a common denominator. And importantly, if you're ever asked to find the lowest common denominator, that's probably the best way to do it. The other way, which is a little bit sneaky, that you can do is if you multiply both the denominators together, so 3, so this is the other method. If you multiply both the denominators together, so 3 times 4 is 12, that will give you a common denominator. It might not give you the lowest common denominator, but it will give you a common denominator. So our first step was to identify a common denominator, and in this case it's 12. Now our next step is then to change both of these fractions so they have a denominator of 12, and that's going to help us compare it. So let's start with 2/3, and I'm going to use the same layout I used before. So I want the new denominator for this fraction to be 12. I'm going to ask how I've changed the denominator, how the denominator has changed from the original fraction to the new one. So how have I gone from 3 to 12? Well, I've multiplied it by 4, and therefore I'll have to do the same to the numerator if I want to keep it as an equivalent fraction. So 2 times 4 is 8. So 8/12. So 2/3 is the same as 8/12. Okay? Now I'm going to have to do, that was very similar to the last method we looked at. I'm now going to have to do the same thing to the other fraction, because even if I substitute in 8/12 for 2/3, they're still not the same denominator. So I'm going to do the same thing. I'm going to take my 3/4, and I want this to have a denominator of 12. So again, I'm going to ask, how have I gone from 4 to 12? And I multiplied by 3, and you'll notice actually a little pattern emerging here. You're multiplying by the same as the other denominator. Well, I've got lost in my train of thought then. Okay, where have we got to? Oh, we've identified what we multiplied by. So we have to do the same to the numerator if we want to keep it as an equivalent fraction. So multiply that by 3. 3 times 3 is 9. Okay, so now I'm just going to rewrite those with their new fractions in there. Okay, so we started with 2/3 and 3/4. The equivalent of 2/3 with a denominator of 12 is 8/12. Just check up at the top there. Let's check again. Yes, 8/12. Okay. There we go. Let's get a bit neater. And then 3/4 with a denominator of 12 was 9/12. Okay, so once again, these are equivalent. So we haven't changed the amount of the fraction, we've just changed the amount that it's been split into. And now we can see which one is bigger. Well, the 9/12 is a bigger fraction because it's got a larger numerator, which tells us that 3/4 is larger than 2/3. So that is how we can find equivalent fractions for ordering and comparing fractions when neither denominator is a multiple of the other denominator. Okay. In the next video we'll look at how we add and subtract fractions, but until then, keep having fun with your equivalents.